One day you're at a fair and you're taking part in a multi-team tug-of-war. In the center is a ring with 5 ropes connected to it, and at the end of each rope is a tug-of-war team. Once the war begins, all 5 teams pull as hard as they can. Some pull with large forces, some with smaller forces. But which direction does the ring move? Which way does it accelerate? To figure out the answer to that question, we need to find the sum total of the force vectors of each of the teams. If 2 teams pull in opposite directions with the same force, they'll cancel out. But with the number of forces that can be involved in real-life situations, there's no telling what the overall force will be. To figure out the overall force, we have to add up the force vectors. A similar thing can happen with other kinds of vectors. If you're walking on a moving train, while the Earth itself is moving around the Sun, and the Sun is orbiting around the center of our galaxy, your body has a lot of different velocity vectors. If you wanted to know your total velocity, you would have to add those up. There are 2 main ways of adding vectors, mathematically and geometrically. In this lesson, we're going to go through the geometric approach, adding vectors tip to tail. To avoid lots of messy math, the geometric approach has a nice simplicity to it. All you have to do is draw a diagram. Of course, you do have to draw a very accurate diagram, a scale drawing. A scale drawing is a drawing where the lengths and angles of every line relate to each other in a consistent way that matches the reality. So for example, with a force vector, you could say that every centimeter is equal to a force of 10 newtons. So a 50 newton force vector would be an arrow of 5 centimeters in length. To get the total of 2 vectors, you draw them to scale and put the tail, the backside of the arrow of one vector, against the tip, the point, of another vector. Here, for example, we have 2 force vectors pushing on a block. One person is pushing the block down and to the right, the other down and to the left. We move one of these vectors onto the end of the other. And if this diagram is to scale, we can find the total by drawing a vector arrow from the very start to the very finish. This vector we've drawn is the total. The vector for force 1 plus the vector for force 2 equals force total. We could then measure the length of the arrow in our scale drawing and the angle in which the arrow is pointing to figure out some numbers for our total force. Maybe this will be easier if we went through an example. Let's go back to the 5-way tug-of-war, but let's make it 3 teams to be simpler. Here is the scale drawing of the forces on the ring in the center, and the question asks us to find the total force using geometric approaches. Well, all we have to do is add up the 3 force vectors tip to tail. Move this one over here, and this one over here. Then draw a vector from start to finish. And that is our final force, our total force, which tells us the ring will accelerate in that direction. We measure the arrow and it turns out to be 3 centimeters long, which based on the scale is 60 newtons. And the angle that this force is pointed at is 25 degrees. So the total force on the ring is 60 newtons at an angle of 25 degrees measured from the positive x-axis. And that's it. That's our final answer. In the real world, there are often many vectors acting in one situation. Many forces acting on the same object, many velocities, many electric fields, all of which are examples of vectors. To figure out the net result of all those forces, or velocities or fields, especially when they're pointing in all kinds of opposite-facing directions, we have to figure out the total. We do that by adding the vectors together. We can add vectors mathematically or geometrically. To do it geometrically, we have to create a scale drawing. Then we take the vectors we want to add and reposition them so they're tip to tail. If we draw a vector from the very start to the very end, this will be our total. Its length will be the size of the total, and its direction will be the direction of the total. As long as everything is drawn to scale in both length and direction, we can just measure our final arrow and have our answer. And that's all there is to adding vectors geometrically.